Okay, so now we learn how the hat method can be used for samples, but should we use it for all samples? The problem is sometimes your sample frame will be quite large, so it might need some big hats, and it's going to be time consuming cutting all those little pieces of paper, making it pretty impractical and killing a lot of trees. So what can we do instead? We can actually assign a unique identifier to each individual in your sample frame. Either student IDs, line number works pretty well, and get a list of random numbers, either from a random number table or a random number generator. Use the outcomes from that list to select the sample. Explain any digits which will be ignored. So which ones are you going to ignore? And ignore the repeats because we don't want to have, you can't have the same person in the sample twice. They can only be once. And I should say individual because it's not always people. And you stop when you get to the desired sample size. So let's go ahead, and sometimes it sounds really easy, and there are different ways to do it. Sometimes it can get kind of complicated depending on how you set it up. So here I have the example in your notes. An 8-floor hotel with 30 rooms on each floor has 96 of its rooms facing the ocean, another 48 with a partial ocean view, and 96 facing inland. Room numbers have the first digit from the floor number and the next two digits from 1 to 30 for each floor. Rooms facing the ocean cost the most, partial ocean views next, and inland rooms the least. If the hotel manager wants to survey 20 guests, how would he select them using a simple random sample? So here on this screen, I'm actually going to use the room numbers. Actually, the easiest way is to just take the rooms and number them 1 through, let's see, how many do we have? 96, 96. That would be basically, hold on a second, I'm going to make this easier. 244 rooms, right? So you could just go 1 through 244 and generate numbers from 1 through 244 and ignore anything else that's outside of it. But you can also use the room numbers. So I'll show you how to do that. So you select 3 digits for each room. The first digit represents the floor number, and the second digit represents the room number. Ignore all outcomes above 830 because there are no rooms 831 or 9, whatever, because it's only 8 floors. Also ignore anything below 101 because in the US we don't start on floor 0. In Europe they do, but we don't. Also, you want to ignore the following ranges where there are no room numbers corresponding to it. So 131 to 200, 231 to 300, 331 to 400, etc. Now, since we cannot select the same room twice, we got to ignore repeats and keep gathering room numbers until you have 20 rooms to survey. So you can see it's probably easier actually to go 0 to 243 and just randomly pick from there. So there are different ways you can do it. This one's a little more complicated with the room numbers because there's so many different ranges you have to ignore. What if you're concerned about missing certain groups? For example, if we're doing a random sample at Cedar Ridge for the prom, we want to make sure we have seniors and juniors. So what we could do is randomly sample in English 4 students and then also randomly sample among English 3 students. These are based on strata, which are groups or classes in a population that share a common characteristic. So English 4, those are seniors, and English 3 are juniors. There are many different types of strata. You can stratify based on age, income, education, location. And we call this a stratified sample when you create strata and then do your random sample within each of the strata. A lot of times you're going to want to do a proportional allocation, which is where you're matching the sample size to the population percent for each strata. How do we do a proportional allocation? Well, you determine the percent each strata make up and multiply that percent in decimal form, not in percent form, times the desired total sample size. So if you want 20 people, you multiply it by 20 to get the number of individuals for that sample from that strata. So let's take a look at our hotel again. So if he wanted to create a stratified sample, how could he do it in a proportional stratified sample? Well, we can divide up the rooms according to type of view. and look at what percentage they make up. We've got ocean view is 96 out of 240. Actually, I'm pretty sure that's 240. Let's see, 240. Yes, 96 out of 240. I said 244 before. And you have inland is also 40% or 0.4, and partial, which is 20% or 0.2. So your sample size, well, what you're going to do for ocean and inland, those are both 40%. So we just need to do one calculation. 0.4 times 20, so we're going to do 8 ocean rooms and 8 inland rooms. For the partial view rooms, that's 20%, so we go 0.2 times 20, that gives us 4 rooms. So we can number the rooms from 00 to 95 for both ocean view and inland, or 00 to 47 for the partial view, and then randomly sample until we get, we're going to pick 2 digits to represent the room, ignore out all outcomes outside of the ranges, and then we're basically going to draw rooms until we get the desired sample size. So we would draw from the ocean rooms until we get 8, from the inland rooms until we get 8, and the partial view until we get 4. Can we do clumps instead? Sometimes it's actually a lot easier to do clumps of people. And for example, we could, instead of trying to randomly sample among all the English 3 classes, because there are a lot of English 3 classes, we could just pick 1 or 2 English 3 classes, maybe even 3, and sample those. We could do the same thing for the English 4 classes. And basically, we would be using clusters, groups of individuals located near each other, making it easier to get access. So when you're creating a cluster sample, you're going to determine how to classify your sample frame into clusters. You're going to do, you're going to basically kind of put an identifier on each cluster. So each of the English 3 classes would get an identifier. And then you do a simple random sample of the English 3 classes, and you get your clusters there, and you do the English 4. Actually, because I'm doing English 3 and English 4 separately, this is kind of a multi-stage sample. But if I was just wanted juniors and just did a few English 3 classes, that would be cluster sampling. Careful, cluster samples are valid only if the clusters are representative of the population. So if there's some reason to think an English 3 class doesn't represent the juniors, then this would not be a good method. All right, so we're going to take a look at the hotel sample. And basically, cluster sampling is really easy on the hotel. You basically randomly select a floor or 2, you can do 3, and sample all the rooms on the selected floor. And the nice part about that is you'd have the right percentage of ocean view, the right percentage of partial view, and the right percentage of inland view in your sample. So all your strata would definitely be represented because the clusters are similar. Each floor is like the other, all right? Maybe you could argue, well, maybe the top floor is a little nicer. They pay a little more to be on the top floor, but some people like being on the bottom floor. So I'm not sure there's that big a difference. Now, sometimes you don't have all your people in a pool and they're like coming in, standing in line, and they're joining the line. So you don't have everybody there at the same time. So in our prom example, we could see a group of seniors in line for their photo. How could we sample them? Well, not all the seniors are going to be there all at once. So it's not like we can put their names in a hat and draw from there. What we could do is we could interview every 10 persons. Now, to make it random, what we're going to do is randomize where we start in the line, okay? So we would use a random number table or generator to pick someone from the first 10 as a starting point. This is called systematic sampling, where you randomly determine your starting point from your first K individual. So if you want to sample every 10 or every 20, and then you sample every kth individual after that. So if you're doing every 10, every 10th individual, every 20, every 20th individual. Careful, there should be no pattern in the order that might affect the responses. So I can explain that a little better. You're like, well, why would there be a pattern in the line? Well, if you used it for like a building, like our hotel. Well, first of all, if he just does it at checkout where he randomly picks a starting point and then samples every 5th person at checkout, that would work. That would be fine as long as there's no reason to think that there's something different about every 5th person. But let's say he randomly picked a room on the first floor and then picked the corresponding room on each floor. you'd have to be careful because you're going to end up with people with all the same type of view, and that would not be representative of your population. Finally, we have multi-stage sampling, and that's basically a combination of sampling methods. And you end up using it quite a bit in bigger, more complex populations. Census Bureau uses it for their National Health Interview Survey. So they'll do a probability of a sample for 42,000 households, but they basically put the households in groups of into 376 groups. Then they basically pick from those groups, and they're chosen in groups around 4 adjacent households. So as you can see, it's a little bit complex. The Gallup poll, they might randomly choose a certain number of area codes, then randomly sample a couple of phone numbers, many phone numbers from within each area code. So initially, if you do area codes, it's like you're picking clusters, but you're not going to interview everyone in that area code. So you're going to do it's almost like stratified. You would basically randomly sample them within the area code. And of course, Johnson's did a survey on drug use in high school, and they did 3-stage sampling. They did geographic area, followed by high school, and then followed by senior students. Now, one thing, you've got your sample. All right, so you've done one of these sample methods. What if you don't get surveys from them? Is your sample still good? Well, it could suffer from non-response bias. And that's when an individual is chosen for the sample, but either can't be contacted or says, no, I don't want to participate. For example, you hand out a survey, but some individuals don't turn it in. So that would be kind of, well, they might have different views from the people who turn it in. That could cause some issues. Say you survey students the Friday before spring break. Well, I'm going to tell you right now, lots of seniors are absent the Friday before spring break. Not that I approve, and I don't. So you would be missing a lot of seniors. You could survey residents of an apartment during working hours, in which case you would miss the people who are at work and they can't respond to the survey. Now, if you get people who don't refuse, but you believe your sample's still representative, then maybe you won't suffer from this bias.